Okay. Good morning, everyone. My name is Jeet. I'll be taking your stats sessions. So since you're kind of new, this is the first class we're having together. Can we start with like introducing ourselves, like a little bit about ourselves? So I'll start with me. My name is Jeet Shah. Uh, I've been like conducting training for Digital Vidya since the last year, and yeah, I just hope to have make this session as enjoyable as possible. Uh, Anyone wants to like introduce themselves? I know probably you all know each other, but I won't know you also.
Hi, good morning. My name is Shudipto. Am I audible?
Yeah.
Yeah. My name is Shudipto. I am MCOM and PGDBM. I have joined this class, and I'm working right now with a digital marketing company.
Okay.
Uh, and I joined this class to know more about, the dashboard, Excel, and things like that.
hmm Okay. Great. Thanks, Sudipto. Anyone else? So by now you all have hopefully mastered Excel, at least a good understanding of how it works, right? Yeah. So come on, guys, just introduce yourselves. Okay, Diptesh says he works with Coach Group and he's into project sales. Okay. Gaurav currently living in Delhi, working as analyst. Okay, great. Hiral working for NBN. Good. Ankur working from Pune, working in product management. Okay. Okay. Hiral, can you tell us what is NBN? Vishal decide. Uh, Currently working in B2 retail as merchandiser planner. Cool. Oh, okay. One of the service providers in Australia. Great. I'm currently living in Bangalore. Oh, you had an undergrad and stats major. Okay, so perhaps this will be a very simple class for you. Set of sessions. Okay. Currently pursuing MBA, actually from Kolkata. Okay. Great, Arnab. Okay. 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 Great. Thanks, everyone. So we'll start with the bare basics of statistics. I'm sure not everyone will be like very comfortable with this. So let's start with the bare basics, right? Yeah. So first of all, I'll just take you through what we will do today. We'll first of all see what stats is. We'll get a good introduction to that, right? And then we'll go through these few topics, which is samples and population, random variables, probability, data set distributions, central limit theorem, descriptive stats with all of these in it, right? So we'll just go through each of these topics and just understand what they mean, right? And how to use them. Okay. Now, guys, if you want this session to be very interesting, not like a boring stats lecture, you should ask whatever kind of questions you have. If I have the answer, I'll answer it now. If I don't have the answer, find out and answer next time. Clear? Okay. Okay. So coming to statistics, right? Statistics is all about studying numbers, right? So studying numbers in the sense what they are trying to indicate, what they're trying to say. That is what statistics is all about, right? For example, we have these two big, there's like a two sections of statistics, which is retrospective analysis and prospective analysis. Okay. Now these are just fancy words for two aspects to statistics. Retrospective analysis basically means understanding past data, right? What, how it was, and how it affect, uh, as in just understanding how the data was, right? Uh, Now, based on this past data, if you want to extrapolate or understand what is going to happen in the future, right? If you want to get a good prediction of how will the future look like, that is prospective analysis. Is this clear? Okay. So one is based on past data, the other also is based on past data, but it's about the future. Okay. These are the two main parts of statistics. Okay. Now, statistics is all about asking the right questions. Okay. So I'll tell you what I mean by this in a bit. But a lot of times the question becomes more important than the solution, than the answer. Okay. So just for an example, I'll just take you through this. So this chart you're seeing here, this diagram is of a fighter aircraft from World War II. Okay. This was, I think, sent by Germany as part of the Air Force to other countries in battle. Uh, and they realized only some, like maybe a few, let's say they have 10 aircraft like this, only about 3 or 4 would return back. The rest would be gunned down, right? Now, in this diagram, you can clearly see these are the diagrams of the aircrafts that returned, okay? These red dots here are basically where the bullet marks were found, okay? Right? Now, the the German army was asked a question basically as to how to fortify the planes in such a way that they don't get gunned down so easily, right? So they were asked a simple question saying, okay, which part of the aircraft should do you think should be fortified? Like there should be more armor on it, right? So, for example, there's the engines, right? There's the wings, right? There's the tail, okay? And the central portion is called the fuselage, okay? So, I'll put the same question to you all. Looking at this diagram, okay? What parts of the plane do you think should be fortified or strengthened? Everyone, just take a guess. Think a little bit and say whatever you have to. Okay, Arnab says the wings. Okay. Sudipto also says wings. Anyone else? Wing. Okay. Okay. Center part of the plane and the wings. Okay. Okay. Mhm. Come on, there are 10 people. I should get 10 answers at least. Anyone else? Okay. So I think more or less everyone agrees it's the wings, right? And the central part of it, right? But now, this is actually a real incident that happened, okay? Sorry. So basically, what happened was there was this one guy in the German camp who said, no, there's no need to fortify this. We should fortify the engines, right? Now everyone got puzzled. They're like, why the engines? There's like hardly a couple of bullet marks over there, right? Most of the damage is on the wings. But this one guy, he had such a valid point. He said, okay, but these are the aircraft that returned, right? The ones who didn't return obviously took hits on the engines, right? See, these have taken such a bad beating on the wings and the central part of the plane, and still they've returned, right? But the aircraft that has not returned has either gotten in the fuel tank or the engines, right? So that is what should be fortified, not the wings. Does everyone get the point? It's brilliant, right? Yeah. Yes. Yeah. So Bhanu says it perfectly. A single damage in the engine can make it explode, right? Same for the fuel area, right? Okay. So this was just to give you an example of how to think. Okay. Yeah. Yeah. Okay. So if you keep this in mind, just make sure your questions are right, right? They're much more important than the answers, right? Answers, even if you can't find right away, you'll find it eventually. But that is only true if you ask the right questions. Okay, is this clear to everyone? Yeah, looks like. Okay. Okay. So the rest of the presentation will be mostly me explaining certain jargon. Okay, making it simpler so that we can understand, right? And certain theories that are very much key to any kind of statistics that you do. Okay. So first we'll tackle randomness. Okay. So randomness is basically the nature of life, right? That's what statistics wants to get an understanding of. It wants to put some sort of logic behind all this randomness in life, right? So, studying randomness is a big part of uh, statistics. Okay. So, what do I mean by this? So, let's define randomness actually first. Randomness is the lack of pattern, right? Is this much is obvious to everyone? Okay. So you cannot really predict what is going to happen next. It'll all be random, right? Uh, it's a random sequence of events, symbols or steps that has no order and does not follow any kind of pattern or combination, right? Uh, so if you look at this first image here, right? There are a number of dots that are kind of scattered around, right? You cannot really make out what that is, okay? But before you go and see the second image, just read this point. It says individual random events are by definition unpredictable, right? But in many cases, this is the key part, okay? But in many cases, the frequency or the number of time an event occurs, which is frequency, of different outcomes over a large number of events is predictable, okay? Now, this seems contradictory, right? Because I am saying randomness is a lack of pattern, but the moment you get a huge number of random events, it's very likely that you'll start to see some sort of pattern. Okay. Now, these same dots, if you just arrange them in a certain way, you see the second image is starting to look like a flowing cloth or something, and it's the same amount of dots, right? This is just to give you a visual representation of how randomness behaves in real life. Is this clear to everyone? So I'll give you a real life example. If you're walking in a forest, right? There's like so much going on. There's like trees here and there. You can't even uh, look up and walk. You'll have to look down, see where you're putting each step, right? If you're going trekking, and yeah, basically you have to take care of each step that you're taking, right? But suppose you have a drone, okay, and you send the drone up and you get a whole capture of the forest, then it really looks beautiful. It looks like one uh, uh, like clean, neat, area where you can go and have fun. But it's actually there's a lot going on inside, right? So it's all about perspective, right? If you have enough data points, you will start to see some sort of pattern, right? We'll look at a few examples of this a little later, but that is what randomness is basically, right? So now, why is this important? Because life is most of actually all of the natural events in life are very random, right? Especially departments like the weather department, they have to deal with this on a daily basis, right? Because they have to actually give some sort of prediction based on completely random natural events, right? They use statistics a lot, right? Okay. So a few examples of randomness in real life are dice, coin toss, and cards, right? I've taken these three because these three you'll always find in any stats book as like standard examples because everyone can relate to this, right? So we'll also be doing a few of these examples. Okay. Uh, Now there's another key term here which is called random variable. Okay. Now the variable is a key word here. Now variable basically means uh, whose possible values are outcomes of a random phenomenon. Okay. So the random variable of dice would be 1 to 6, right? The random variables to a coin would be head and tail, right? The random variable to the cards would be all the 52 decks, 52 cards, right? Is this term clear to everyone? Random variable basically means what are the possibilities. Okay. Yeah. Okay. So there are two kinds of variables. There is continuous variable and categorical variable. Okay. So continuous variable can take any score within a measurement scale. Like for example, you have inches and feet, right? You can take any measure in it. You can take 1 inches. You can take 2.25 inches, right? You can take 1 feet 3 inches, right? You can take any score, even to a decimal point. Okay, uh, and the difference between each of those values has a real meaning. Uh, so if you want to compare 6 inches to 8 inches, there is a real difference of 2 inches that you can compare, right? Okay. Uh, so some other examples include income, temperature, height, weight, etc. Right? Uh, can everyone think of a few more examples of continuous variables? Just quickly think of some more. Profit and loss, perfect. Report cards, okay. Marks, you mean? Yeah, perfect. Cricket score. Yeah, sales. Yes. Okay. Yeah. I think we have enough examples. Thanks. Okay. Then there's another set of variables, right? Which is categorical variables. Okay. It is basically made up of categories like A, B, C, D. Okay, which basically is like gender, for example. It's either male or female, right? Or race, right? Or marital status. Okay. So I think this kind of makes it very clear as to what categorical is. So if I take something like dice, okay, does that come under continuous variable? It is a number, right? You get either 1, 2, 3, 4, 5, 6. Or is it categorical variable? Can anyone tell me? Okay. Oh. So Madan says it's category. Bhanu Singh says it's continuous. Anyone else? Okay. We have like a divided house. Anyone else? Okay. Gaurav says category. Okay, sure. Arnab, I'll repeat. So if you have, for example, dice, right? Dice. Does this fall under categorical or continuous variable? It's numbers, right? Bhanu Singh, that's true. But which kind of random variable is it? Probability comes later. We'll be calculating that also. Okay. Sudipto says continuous. Ashit, Ashutosh says continuous. Okay. Arnab says continuous. Okay. Oh, okay. Okay. So I'll ask you one question that will make it very clear to you. Okay. Yeah. Someone wants to talk? Someone's mic just went off. Okay. So, can you tell me, can I have a dice roll to 3.5? Yes or no? Ah, right? So, even though these are numbers, they're actually like categories, right? Either you get 1 or 2 or 3 or 4 or 5 or 6. Yes. Madan, randomness can be expressed in decimal. So, good you brought this up. So, even though we are using the dice to experiment with randomness, okay, this the random variables that we get out of a dice, right, are basically the categorical type. Okay, simply because see, if you just read this, can take on any score or value within a measurement scale, right? So, for the example of a dice, can you take the dice, like, can you get any number between 1 to 6, including decimal points? Yes or no? Obviously, no, right? Okay, so that means it's not a continuous variable. Okay, see, let's check with the second point. Okay, the difference between each of the values has a real meaning. Okay, so for example, if you have if you roll the dice once and you get a 2, okay, and you roll the same dice a second time and you get a 6. Do the two values mean anything to each other? Yes or no? Can I do 2 minus 6 or 2 plus 6 to guess the next one? No, right? It doesn't make sense at all. Okay, so it does not fulfill both these uh, criteria, right? So it's not a continuous variable, even though it is numbers. Okay, it is a categorical variable because it has clear categories. You cannot go between those categories. Is this absolutely clear to everyone? If anyone has a doubt, you can ask. Okay, 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 great. Yeah. So that was randomness. Pretty simple to understand, right? Okay. Uh, Next, I'll come to samples and populations. Okay. Now, this is another like big uh, base for statistics to stand on. It's a pillar of statistics. Okay. Now, I'll start with population. Population is basically anything, any collective that you want to check for. Okay. So, for example, a population is total number of individuals, animals, items, etc. for any given subject. So, for example, if you want to do a survey for some sort of toothpaste, right? You can ask everyone who uses that toothpaste. Okay, that will be a whole population. Okay, whether we can do that actually or not is secondary, but just understand what a population is. Population is basically everyone concerned for that particular topic, right? So, for example, if we have to vote, everyone who's an Indian citizen would be included in the population, okay, or in the uh, whole set of group that you need to vote for, okay. So that is the population. Now, the problem with the population is you cannot ever survey the entire population, okay. Now, suppose let's take for example, you want to take a vote on whether uh, okay, I can't think of a good topic, but let's take the general elections, right? Suppose you have general elections. Can you ever get each and every person in this country to give a vote? Is it always 100% yes or no? No, right? Even though our like election system is like a major phenomenon in the world, it's like a huge task that they take up. Nowhere else in the world we have such a such an amazing like election system. Okay, but still we are not able to do 100%, right? This is because of logistics and various other reasons, right? So what statistics does is it will always try to take a sample, a representative sample, okay, which will decide for the whole population. Okay. So a sample is basically a smaller, more manageable version of a larger group. Okay. So for example, if you want to uh, uh, like get an opinion about some sort of medicine from doctors. Okay, Diptesh just shared a good example. He's saying exit polls result to predict the winner. Yes, that's a very good example. Okay, so exit polls are conducted by third parties just to uh, predict who the winner will be, right? So that is a good example of sample. Okay, so you got the point, anyways. So that is what a sample is. Now, samples are mostly done to for these three things, just to avoid the huge costs, right? Maybe you cannot access the whole population, right? There's like boundaries of time that you have to finish. You can't like spend 10 years for a vote. Okay. Bhanu Singh has another one. Plastic currency was sampled in a few cities. Yes. Yeah, this also is a good example of sample. Most of these big companies will actually do like a pilot test for with like small samples. Like I'd heard, I think it was Maggie who came out with a chocolate version. I think they tried. Yeah, I can't imagine eating chocolate Maggie, but I think I heard this news somewhere. They were a few years back. They were trying to see if people like chocolate Maggie, but it didn't turn out well. Obviously, that's why we don't have it. Yeah. Okay. Sorry. Yeah. So the key thing about sample is it should represent the whole population and it should not be biased, right? Okay, that is the key thing. Okay. So for example, can anyone just look at this image? I know everyone must have recognized this ad. Can you tell me what is the fault in this advertisement? Okay, Diptesh says 9 out of 10. So Diptesh, can you elaborate a little more? What do you mean by 9 out of 10? If you want, you can turn on the mic and speak. That's completely fine. I meant that they can't reach that number of dogs. Okay, okay. You mean 10 doctors are like a very small sample? Is that what you're saying? Okay, they can't reach all the doctors. Okay, okay. Yeah, got it. Okay. Anyone else? Okay, so Dipto says there are many more doctors. Yeah, obviously. Yes. It's false recommendation. 9 out of 10. No one dentist will recommend like this. Yes, Ashutosh, but how do you know it's false? That's what I'm asking. Okay. What made you understand that there's something fishy about this? Okay. My brother's a dentist. Okay. Okay. No, I'm asking for statistical reasons. Okay. So Rajan Patil says result of one is not shown. Okay. Sudipto says the sample size is not right. Okay. Okay. Ashutosh says SOI. No, no, I didn't get that. Sorry. Acha, so I know. Yeah. No, I'm asking you to think for statistical reasons. Okay. Um, Diptesh Banerjee again says 9 out of 10 quotes is too accurate as large population of dentists. Okay, that's a valid point. Okay, this data may be from certain cities of states, and the data is based on that sample area. True, that is another valid point. Okay, okay. So another big thing that I think all of you know, but you've kind of missed it, sidelined it, is basically, yes, see, Madan said it, size percentage is not mentioned, right? There's no details that you can verify for yourself. Yeah, actually 9 out of 10 have said that. We have no idea of knowing whether actually only 10 dentists were asked, or were 100 asked, or 1,000 were asked. We have no idea, right? And we have no idea also if all these 10 doctors or 100 doctors were working for Sensodyne. Okay, so we have no idea both ways. Is this clear? So this is a very biased ad. Okay, most of these kind of ads are like this, so there's nothing surprising about this. So basically, there's no indication of what's the population. There's no indication of sample. There's no indication of how the sample was chosen, right? Whether these dentists belong to the company or belong to Sensodyne, or they get some sort of commission, right? Or they are completely, picked at random, or they were chosen like all on a certain day, or they might be from a medical college, right? There's no such details given, right? And believe me, even if you try to find out these details, you won't find that, right? Yeah, that's about it. So that is population and sampling. Is this topic clear to everyone? Any questions regarding this? Okay, okay, fine. Mm, so let's go for the next topic then. Probability, putting a number to chance. So probability comes more under prospective analysis, okay, where we are trying to figure out what the future will be. Okay. But anyways, it's a very important part of statistics. So let's just go through this. Uh, okay. A probability refers to the percentage chance that something might happen. Okay. Again, I think this is the wrong word used. It should be might happen. Okay. It may happen, it may not happen. And we can put like a percentage of how sure we are. Okay. So it is usually expressed in a value between 0 and 1. Okay. Like in decimal places. So 0 is least likely. It is absolutely clear that it's not going to happen. 1 means it's absolutely sure it's going to happen. And if it is 0.5%, that means it may happen, may not happen in equal measure, right? So probability helps define risk by quantifying the prospects for unintended and negative outcomes. So basically, it'll help you understand what may happen, right? And this is basically used to avoid risks as much as possible, right? So as you know, many everyday events also, forget about big things, many everyday events also cannot be predicted with total certainty. So anytime you deal with probability, always take it with a pinch of salt. Okay. uh, you'll realize this anyways on your own, but I'm just telling you anyways. The best we can say is how likely they are about to happen. Okay. So probability is very simple to calculate. Uh, this is the formula. Basically, you divide the uh, total number of ways it could have happened by how many number of ways something specific can happen, right? We'll look at practical examples. We'll be doing a lot of probability today. Okay. So this is just the basic of it, right? Data distributions. Next, this thing is basically, so any data, right? Any data that you have, basically, there's some sort of shape to it, right? And I don't mean the Excel kind of shape. It's like a square or rectangle only. Uh, but if you plot any data on a chart, right? it or specifically on a histogram chart. Okay, we'll look at what histograms are also little later, but the data will tend to take certain shapes, right? So these are terms that you will keep hearing on and off. So I'll just clear these for now. So one example of distribution is binomial distribution. Okay, bi refers to two, which means any data which has only two possibilities. Okay, like success, failure, heads or tails, right? Uh, Married or unmarried, right? Male or female. That is what binomial distribution means. So if you have data like that, the distribution would be like this, binomial, right? The binomial distribution is a probability distribution that summarizes the likelihood that a value will take one of the two independent values under a given set of assumptions. Okay. Now I'd like to draw your attention to a few keywords. One is independent. Okay. Uh, so whenever, let's say you have let's take the coin toss for example. Okay. So let's say you toss it once and it comes heads. And if you toss it the second time, it'll again come heads. And you do this for 5 times, and just by chance, all these 5 times you've got a heads, right? So does it guarantee to you that the sixth toss will have a heads too? Does it guarantee to you? Yes or no? No, right? It could be tails also, right? So these two are basically independent of each other, right? So any binomial distribution, right? Any binomial thing will always be independent. Okay. So it will either be this or that. It cannot be both, right? It cannot be dependent on each other, right? Uh, yeah, that's about it. Set of assumptions. I think this is obvious to everyone. I'm not explaining this. Yeah. So when you calculate probability, how that happens is you take a few samples. Okay. Uh, so let's say you want to predict how the coin toss will happen. We'll be doing this a little more in detail, but I'll just explain a little bit here. Uh, so suppose you take 10 coin tosses, and based on this data of what has happened in these 10 coin tosses, you want to kind of predict what will happen in the 11th one, right? There's a formula to that. Of course, it is not dependent on whatever has happened in the past, but we can take a fair guess as to what will happen in the 11th toss, right? That is where the distribution comes under probability. Okay. Okay. So this is a little theory, but just bear with me for some time. Uh, we'll understand this also, so you have a clear understanding of what this means. Okay. Um, for an experiment to be labeled or called a binomial experiment, it must conform to these rules, four rules. Okay. The number of trials must be fixed. Okay. So let's say you're doing coin tosses. Okay, and let's say each of us in this session are doing coin tosses. We should fix a number of tosses that all of us do. So let's say we all can do 100 tosses each, right? This is very important to fix a maximum number of times. Okay. This is just to ensure. So, for example, I test with just 10 coin tosses, and let's say Sudipto Roy will test with 1,000 coin tosses. Do you think our data will be same? Can we compare our two experiments? Yes or no? No, right? Okay. So that's why you should fix the maximum number of times you can experiment at once. Okay. Yeah. Okay. Because it's binomial, the second rule is pretty simple. There are only two possible outcomes at each trial. So every time I toss the coin, there are only two possible outcomes. Okay. Uh, the trials are independent of each other. We've already established this, right? The outcome of one trial does not influence the outcome of the other. Okay. The probability of success at each trial is constant, right? So for each trial, the probability is exactly half, right? It can either be heads or tails in equal measure, right? If it's a fair coin, that's it. That is. So if you have a coin that is that has a little more weight on one side, it'll it'll tend to show the other side more. Okay, so all of this is theory right now, but this is very important to get an understanding later on today. Okay, so these are the four simple rules for any kind of binomial distribution or experiment that you want to conduct. This is one type of distribution. Another type of distribution is normal distribution. Okay, normal distribution, even though it looks simple, it's very familiar. Okay, it looks like a bell curve. I'm sure many of you have studied this also. But the reason why this is important is everything in nature follows the normal distribution. Okay, so basically, I'll come to what it means. So, for example, if you take a large enough sample of, let's take height for example, right? You already know without even trying to test, you'll get most of the people in the average area, right? And some people will be very short, or some people will be very tall. Yes or no? It already makes common sense to you, right? That's how common the normal distribution is. Okay, right? So these are few more examples. I'll just take you through what, in like technical terms, the normal distribution means. Okay. So if I take the average of any data set, right, that will basically become the center point here. Let me just draw. So if I draw a line here, okay, this becomes the mean or the average of my entire data set. Okay. Now, the bell curve or the normal curve is always split equally around the average, okay, around the mean. So, data points near the mean are more frequent, okay, and yeah, okay, and those far from the mean are less frequent, okay. Uh, Another thing is there are three types of averages. We'll be coming to that a little later. So all the three types of averages will be exactly the same in any normal distribution. Okay, there'll be no difference between these three types of averages. Okay. Another thing is, yeah, they are denser in the tails, which is basically the same point here. Okay. Um, More frequent means it's a denser data set in the middle, and in the tails, okay, in any kind of chart, the ends are called tails. Okay, so your data will be less dense in the tails, right? It's the same point in different words. Uh, okay. I think someone just arrived. Okay, so yeah, this second one is meant to be a joke. If you want, you can laugh at it. I'll just move on. So there are some other examples here. So height. Okay. One thing I forgot to tell you was only a large number of real life aspects will follow the normal distribution, right? So what do I mean by this large number? Is if you take a sample of let's say 10 people, it might not follow this normal distribution. Okay, there might be a lot of difference between the heights, right? And there might be no one with the average height. But the more and more number of people you take, the closer it will get to the normal distribution. Does it make sense to everyone? Yes or no? Yeah. Okay. So this is also called the law of large numbers. Okay, where as you get a larger and larger sample, it will get closer and closer to what the actual population is. Okay. All these terms will come up later, but I'm just hoping to give you a more intuitive understanding of these, right? Okay. So, for example, if you have a big enough population, okay, or if you manage to measure the entire population, like let's say all the 7.12 billion people that we have in this world, height, age, weight, right? All of these make complete sense. They'll always follow the normal curve, right? Then maybe the IQ of people, blood pressure of people, okay, insurance claim values made by individuals. Yes, it also happens for non-natural phenomena. Okay, But this holds true again only if you have a large enough number. Okay, if you have a large enough sample. You can see it in scores like test scores, right? Hikes given by employers to the employees, right? You can see it in all sorts of places, with the only condition being it should be a large enough number. Okay. Can everyone think of a few more examples where you can see in where you can see normal distribution from your own like examples, maybe from your own life. Where all can you see normal distribution of data? Just a couple of examples also will do. Okay, Arnab says marks in a class. Yeah. So if you take the whole school, for example, most people will fall under the average category. Some will be below average, some will be above average. Perfect. Blood group of people in class. Okay. Yeah. Like we already know, B plus I think is the most common blood group, right? And I think O is the least common one. Yeah. Okay. I think we have enough examples for this. Okay. So all this, yeah, salaries also is a good example. I know. Great. So let's go for the next thing that comes up, which is central limit theorem. Okay. This is more theory that will kind of verify what statistics is about. Uh, it does not have much practical use, but if you're going for some sort of interview and they want to ask stats questions, this theorem will definitely come up. Okay, so I'll just cover this quickly and then we can move on. Okay, so what does this say? Um, so the central limit theorem allows us to understand the behavior of estimates across repeated sampling from done from a population. Okay, this basically was an experiment or a theorem that confirms the normal distribution. Okay, that's why it's considered so important. Okay, so this experiment I'm talking about is called a Galton board. Okay, I'll just put this in the chat. Okay, maybe after the session, everyone can go on YouTube and search for Galton board experiment. Okay, you'll have a nice video showing you what exactly happens, how did they did the experiment. It's fun to watch also. So basically what happened is they set up this kind of experiment where you just put marbles from the top, okay? And you see each of these points can either send the marble to the left or to the right, okay? Again, suppose the marble goes to the left, again it can fall either to the left or the right, okay? And they put it through this kind of waterfall area, and then they just see where do most of the marbles collect, right? And surprisingly, they found if they put enough marbles, they'll start to see a bell curve here. Okay, see this? Even in this image, you can make out this is more or less a bell curve. Yes or no? So this is what they kind of found out basically. The central limit theorem is all about proving the natural distribution. Okay, normal distribution. Uh, yeah. So this helps us to conclude if any results from a given sample can be declared to be statistically significant. Okay. Now this is the part which is very interesting because unless unless the test follows the normal curve, right? It cannot even be considered statistically significant. Okay. So, for example, the height example that I've given. Suppose you measure just 5 people for height, right? Uh, and you think that is your sample for measuring the height for everyone in the world. Uh, do you think it will follow the central limit theorem? Yes or no? No, right? Why? Because it will not even be close to. Uh, First of all, it's a very small number. Okay, it will also not follow the normal curve, right? So it is not even statistically significant. Okay, that's how important the central limit theorem is. Uh, it verifies the entire statistics that you do. Okay, is this clear to everyone? Yes or no? Okay, great, great. So there are several interesting things you can read through this. Yeah. So as the sample sizes get larger, the distribution of means calculated from repeated sampling will approach normality. That means suppose you take more and more people to measure height, right? Suppose instead of 5 you take 5,000 people. Then you'll get a much more accurate example, right? Suppose instead of 5,000 people you take 5 million people. Then you'll get a much more accurate result. Yes or no? So that's what this point means. Okay. Yeah. And what makes the central limit theorem so remarkable is that this holds no matter what the original population distribution is. Okay. So, okay. So even if you take, um, okay. So even if you take a small sample which does not follow the normal distribution curve, right? Maybe it's a binomial curve, right? But if you take a large enough sample, it will always turn into the bell curve. Okay, that's what this point means. Okay. Then there are a few other points which will make sense if you just think about that. Uh, the mean of all samples. The mean meaning average of all samples from the same population will be approximately equal to the average of the entire population. Does this make sense? This is basically how the surveys and exit polls come up with some sort of explanation, right? Um, So basically, if you study the heights of 5,000 people, you can fairly give an average for the entire population. Yes or no? That's what this means. Okay. Yeah. Okay. So the second point here has this new word which is called variances. Okay. Now variance will come to a little more in detail in like a little bit. But variance basically means how different the data, how away from the average the data is. Okay. Or the spread of the data, right? That is variance. Okay. Uh, so the variance will be approximately equal to the variance of the population, okay, divided by each sample size. This, if you don't get, also is perfectly fine. Don't stress too much about it. Maybe after a while, if you just think about this, it'll make sense. Okay. Uh, yeah, and this last thing here, sorry, as a general rule, sample sizes equal to or greater than 30 are sufficient. Okay, so this number is pretty important for CLT. Uh, so any kind of data set you have should be at least 30 in number. Okay, at least 30 data points to make sure CLT is central limit theorem. Okay, yeah. Okay. So they've come to this number over time. I think they had some sort of studies. So 30 is like considered a good enough minimum threshold for CLT to work. Okay, yeah, that's about it. Any questions regarding central limit theorem? Anyone? Okay, I think everyone's clear. It's simple enough. Okay, yeah. Knowing the data. Okay, so this part is again, I would personally say it's almost at par with knowing how to ask the question, knowing how to ask which questions. Okay, because see, you can think of questions only if you know the data, right? Only once you saw the bullet points in the plain example, right? Where's that going? Yeah. Only once you see this data, only then can you think of some questions, right? Yes or no? Uh, Banu Singh, I didn't get you. What is THY means here? Okay, anyways, I'll ignore that. Um, yeah, so only when you understand the data can you think of valid questions, right? So if I just jump back to that, um, yeah. Mm, okay. So yeah, this is like a quote by Aristotle: "The more you will know, the more you will realize there's much more to know." Okay. So this is another basic rule I want to get into your heads, which is basically know your data first before, like very well before you start to ask questions. Okay. In fact, in the process of knowing the data, you'll get a lot of new questions. This has been my experience. This is where you generate all your questions basically. Okay, fine. So finally coming to yeah, yeah. Yes, yes, like biblical form, right? Yeah. So Madan is asking, sir, possible to explain sample size calculation? You mean for CLT? This 30, are you trying to say, Madan? Okay. So this has just been observed over a long period of time by different researchers. There's no exact match to it. Even if there is, I'm not aware of it. But 30 is considered like a minimum threshold, right? Uh, it is more based on observations by a lot of researchers. Okay. Yeah. So if there's some sort of match, I'll try to research, and like if there is something worth knowing, then I'll let you know next session. Okay. Diptesh is asking, please explain third point also. Okay. Okay, I'll explain that. So actually, Diptesh, can you remind me to explain after we learn variance? It'll be much easier for you to understand. Okay, then it'll get easy for me to explain also once you understand what variance is, right? Okay. This is in case I forget to explain then. Yeah. So coming to the last part of this presentation is classification of statistics. So this is how the statistics is divided, right? So you have descriptive statistics, which is mode, median, mean, okay, standard deviation, variance, min, max, range, okay, and you have inferential. So descriptive statistics will basically describe the data to you, okay. Inferential statistics will help you infer stuff from the same data, right? And all of this is still about the past. See, it's still retrospective analysis, okay. Uh, so inferential statistics is basically correlation, analysis of variance, and analysis of covariance. So we'll hopefully get to cover most of the retrospective analysis today, and then next time onwards we'll do some prospective analysis, okay, which is regression. And yeah, so I think inferential and the prospective will go to next session, okay. And today we'll be learning this. If you want, you can read through these, but we'll be understanding them anyway, so I won't go through this slide, okay. So any questions, any observations apart from that last point for the variance? Okay, no sir. Fine. So guys, let's take a short break. Is 20 minutes enough for everyone? Let's come back here at 10:20. Okay. Then in the meantime, make sure you download this statistics 101 file from the LMS. Okay. We'll be starting like practically using stats in Excel. Okay. So let's meet back here at 10:20. Okay. See you guys. LMS site is not working. Okay, let me check. It does work for me, but I'll just open it fresh. This happened to me in the morning also, but afterwards it started working. So yeah, it's working now. Huh. Yeah, it takes a bit of reloading. Yeah. Okay, so week 8 is what we need, the content. Okay, and the same presentation that I just showed you is also there if you want it. Okay, okay, guys. See, oh, sorry, I gave the wrong time. 11:20. My bad. I just saw it's 11 o'clock. Sorry. Yeah. Okay. Okay, guys, I hope everyone's back. Yeah, great. Okay, so let's start using a sheet itself. Okay, the first thing we'll just see is how to do random variables in Excel, right? Um, so I think some of you might know this already, but you can actually use this function called rand, R-A-N-D, for random numbers. Okay, the random number will always be between 0 and 1. Okay, so if I want, I can just make this once and drag it down. And as you can see, all of these changed, right? So the random function is what is called is a volatile function. Okay, meaning anything else that changes in the sheet, this will recalculate. Okay, so random and random between functions are both volatile functions. Okay, if you want to freeze the answer, what you have to do is say select that, copy it, and paste as values. Okay, I hope everyone knows how to paste as values. Okay, you can even right click and do it. Once you paste as values, it'll be frozen. So now even if I recalculate something, all I'm doing is going on an empty cell and pressing delete. Okay, that's how this recalculates. Okay, once you paste as values, though, they won't recalculate. Okay, and whoever's made the sheet has made a simple button here for refresh. Okay, which will basically uh, uh, just recalculate the sheet. Okay. So this was random variable 1, which is your random numbers between 0 and 1. Okay. Suppose you want other kinds of random numbers, then you use random between. Okay. Now random between me, you can actually set a bottom and a top number between which you'll keep getting random numbers. Okay. So for example, if I put bottom as 1 and top as 10, I'll keep getting random numbers between 1 to 10. Okay. So incidentally, it ended with a 10, but it doesn't usually. Uh, okay, so that's about it. Um Random and random between functions. So let me test how much of Excel do you know. Suppose I want a completely random number that calculates every time I like that every time I click refresh it will calculate again. But I want it like a whole number with a decimal. Okay. So what formula would you apply here? Can anyone tell me? So I want a random number which is like more than one, but with a decimal place. Because see, if I use random between, okay, and I say 1 comma 10, okay, and even if I increase the decimal places for this, you'll see it's all zero, right? There are no decimals inside to show it, right? So how do I get decimal places also? It's a very simple uh, question, but let's see if you can get the answer. It's not even more of an Excel question, it's more of a maths question. That should give you a clue. Guys, sorry, there's some music playing in the background. I can't stop it. It's there in the other building. There's nothing I can do about it. So if you enjoy this music, enjoy it. Otherwise, ignore it. Okay. Perfect. So the has got it. So what he has done is change the random between function, and he has just said plus rand. Okay. So that way he'll get a random between number between whatever he's put here plus another random number. Perfect. So Sudipto, you won't believe sometimes people uh, take like a longer, like a really long time to come up with this. But it's good. Yeah. So sometimes people also do it in two different cells, but this is perfect. Okay. So this is how you get random numbers in Excel. Okay. Right now it looks very useless, but believe me, sometime or the other it will come in handy. Okay. It's good to know it. Fine. Let's go to sampling. Okay. Um, Okay, now sampling, this is not a fancy Excel like feature or anything. It is just like a visual to show you how the sampling works, right? So, for example, now what I meant by bias samples, you'll be able to see all that visually. Okay. So, for example, we have this set of 50 men and women, 50 women. Okay, and we want to pick 18 people randomly. Okay, and we want to make that a sample. Okay. Now, if I just press random sample, it will basically give me a random set of numbers, right? Okay. So, um, if I just press this a few times, sometimes you can clearly see the bias. Yeah. So, for example, this, right? Do you think this is a very good sample that we have? A very balanced sample that we have? Yes or no? Okay. Diptesh, why? More males. Okay. That could be one. Okay. Anyone else? Okay. So, Diptesh, again, the question should have been so ideally, you all should have asked me the question, what is the sample for, right? Does the gender difference matter, right? So, for example, uh, yeah, I'm assuming everyone will say it's not a balanced sample, right? But hear me out for a second. Again, I'm coming back to that first thing that we learned today, which is questions are more important. Okay. So, suppose this sample is to get a survey done for toothbrush. Okay. Is this particular XYZ toothbrush comfortable or not? Right. Then this is a very balanced sample, as in it won't really matter which gender they are from. Correct? Because both have uh, the same kind of teeth, and it'll be okay to have this kind of sample, right? But if you have something like which is very uh, gender specific, like to females, okay, like for example, like a question, I can't think of a question. Sorry. Any females in the class? Can you help me, please? Okay, suppose let's take is a handbag very useful or a very attractive, right? Then this would be a very bad sample for that kind of question, that kind of survey. Do you get my point? Yeah. Uh, okay. So that's basically what this had. I had to kind of make you visualize this. So again, depends on your question. So if you have a gender neutral question, then this sample will work. But for the handbag survey, this is a really bad, bad sample. Okay. So that's what random sample means. You just pick a few random individuals. Now, sampling में why is randomness helpful is it helps you to be as less biased as possible. Okay. So, for example, this was your entire classroom. Okay. And you knew what people have what preferences. Suppose all these 100 people are your friends, right? And you know more or less what preference each of them have, right? Then if you try and pick on your own people, then you might be biased, right? But in a random sample, that possibility of being biased gets reduced a lot. Okay, is this clear to everyone? Yeah. As to how this was built in Excel, someone has done used macros, and basically conditional formatting and a few numbers. So yeah, there's no need to go into that. If you want, you have the sheet. You can open it up and check. Right? Okay. So that was random sampling. Uh, Then we come to probability. So now we'll spend a little time here. Probability is basically we'll we'll try to calculate the number that will help us guess the next case. Okay. So does anyone remember the formula that I showed in the PPT for probability? Suppose we have this one coin toss and we want to know the probability for heads and tails. Should I go through the PPT again? Let's see. Yeah. So looking at this, what should the formula be for us to calculate the possibility of getting heads or tails? Yeah, perfect. So in this coin example, what do I write here? Okay, I'll say equal to number of some ways something specific can happen, right? So how many ways? No, I got that. But what? How do I write this in Excel so that I can know the probability of the coin toss? So see, we have one coin. Okay, uh, we'll flip it once, right? And we'll either get heads or tails, right? So the total events become how many? The total possibilities. So no, total possibilities. Two, right? So two divide by how. What are we looking for? Let's say we are looking at how probable heads is, right? Then we'll say one. Okay. So we know it's exactly 50%. Sorry, one divided by two. My bad. One divided by two. Okay. So we know it's 50% exactly. Okay. Same thing if I take the example of a dice, right? How many possible events do we have in the dice? Six. Yeah. So I say equal to okay, six. And suppose we are looking at rolling possibility of rolling the number uh, two. Then how many possibilities do we have? Sorry, how many are we checking for? One. Perfect. So one divided by six would give us the probability of getting a of rolling a two in the dice, right? Which is 17%, 16%, right? 16.67% to be more accurate. Is this clear? Is the calculation very simple to everyone? Yes or no? Yeah. So this whole sheet here is just to expand on the simple calculation. Okay. So for example, so we'll write down all the possibilities. Okay. This is just a lot of elaboration, so it's absolutely clear to you, right? So for one coin, we have these two possibilities, right? And now these two possibilities, let's say possibility one, we could have one heads and zero tails. Second possibility is we could have zero heads and one tail, correct? Now we can put this in what is called a distribution, in a probability table, right? So we can put we have two probability tables here. One is for heads and one is for tails, okay? For each possibility. So first possibility, the heads is zero, right? Number of times it can happen is zero. Count of times it happened is just a sum, okay? It's just a count actually of how many times it actually happened. Again, heads in the second possibility, you have one possibility, right? Uh, so again, tails, you can either have it in the first one or the second one, right? Similarly, you can, they've just made a graph out of this. See, right now it doesn't make sense, but as the number increases, this will make more and more sense to you, okay? If I just come here, basically we have just calculated the probability. So it is how count of how many times it happened, right? Divided by the total number of times it can happen. Okay. So you could you could easily get heads twice also, right? Both the possibilities. That's why the sum is two. Okay. Yeah. This is basically just a chart explaining the same. But now if I go to the next section, right, which is two coins, this will make much more sense now to you. Okay. So if we have two coins and we want to toss them, right, there are four possibilities that we have. Make sense? Right? So in possibility one, we could have both heads. Possibility four, we could have both tails, right? Then we could have heads and tails, and we could have tails and heads, right? So this is basically just getting a count of how many possibilities there are. Okay. So the first, how many? What will happen in each possibility, right? Just get a count of that. So in the first possibility, we have two heads and zero tails. Second possibility, we have one head, one tail. Again, third possibility, we have one tail, one head, right? And fourth possibility, we have two tails, right? Now, if you see this will make little more sense now. Okay. So again, we have this table here which just counts how many number of times it's possible, right? And you have the chart next to it. I think everyone can make out the normal distribution is starting to happen. Can you see it? Okay, with the exactly divided possibility, it was not really visible. But the moment you have little more data, you can start to see it, right? Okay. So now again, this is like further expanded, and you have the percentage-wise probability chart. Okay. By the way, guys, these are simple column charts. Okay, there's no such thing as a probability chart in Excel. Okay. Same way, if I go to more number of coins, like three coins, right? So you have so many possibilities, right? But now, can anyone tell me? Uh, Suppose I have three or maybe 30 coins, right? Can I go on listing all these possibilities manually? It will become really huge, no? So if I scroll down, someone has actually written all the possibilities for nine coin tosses. Okay, and you see this is a huge list. Okay, it goes down to 512 different possibilities, right? So if you want to find out the different amount of possibilities, what can you do? Is there like some maths you can do? How can you get a count of all the various possibilities? Yeah, you need not list them every time, no? One by one. So how do you arrive at the number of possibilities something holds? Anyone? Okay. So for example, I have let's try with 2 coins, right? So I have two coins, okay, and there are two possibilities. So I can say 2 raised to 2, which will give me four possibilities. Okay. If I have three coins, okay, I'll say three coins, and again I have two possibilities, right? So I get nine possibilities. This makes sense to everyone. I think the person has forgotten to write one possibility. Does this make sense to everyone? Okay. Again, if I have four coins, I'll say equal to 4 raised to two possibilities. Yeah. So I have 16 possible answers. Okay. Can you try on your own how many possible answers will the 5 coins get without looking at the sheet? 25. Perfect. Okay. So wait, 25. No, no. Wait, either I'm doing something. Sorry. My bad. I think I got it wrong. So 5 raised to 2 is 25 only. Wait, let me check. Sorry, guys. I'm a little distracted. Where gone? Just 1 second, guys. Okay, raised to the combination. Sorry, I got it the other way around. So if we say two possibilities raised to how many coins we have? So 4, right? 16. if we have two possibilities raised to the number of coins we have, which is 32. Yeah. Sorry guys, I just told you the other way around. I'm so sorry. It's actually the number of possibilities, okay, raised to the number of coins you have. Okay, so in the case of 5, I have 5 coins, so it will be raised to 5. Okay, yeah, perfect. So similarly for 9 coins, you will have equal to 2 possibilities raised to 9 times, which is 512. Is this clear to everyone? Is there a shortcut to count possibilities? Okay, yeah, okay. So this will help a lot. Yeah. So if you want, you can go through this entire sheet for probability on your own. In your assignment, you'll have plenty of questions to practice. Um yeah, so just for practice right now, just can you calculate the probability of getting, uh, let's say, a heads in the coin toss of 4 coins? Okay, so find out probability of heads in coin toss of 4 coins. Okay, can everyone just solve this question? You'll have plenty more in your assignment for this week, but just to start off, just calculate the number of possibilities for 4 coins. Okay, 16, and then we are looking at one possibility, right, which is heads. Yeah, which is 4. Okay. So the percentage basically comes to 6.25% chance. Okay. Okay. Any doubts in like probability calculation, or can I move on? Or maybe I should just give you one more question so you're absolutely clear. What's the probability of getting red a red card in a deck of cards? Okay, so if you pull out a card randomly from a deck of cards, what is the probability of getting a red card? So you'll have to count basically. If you need an image of the cards, I think I have it somewhere. uh, yeah, so just an image of the cards if you want. So by red I mean any red card. So Bhanu Singh has said 5. Yeah, 0.5, so 50%. Okay, perfect. It's easy because half the cards are red, other half is black. There's no other color, right? Yeah, perfect. Okay. So can you tell me what will be the probability of getting uh, let's take red hearts? Okay. Then this will be a slightly different. Yeah, perfect. Okay, that was damn fast. 0.25. Okay. Yeah. Okay. So now you know how this kind of works. Okay. So if you have any doubts, ask. Otherwise, I'll move on to the next thing. See, once you understand the theory, the calculation part is really simple, no? With computers. Unless you're doing the calculations with like pen and paper, then it's a little long. Okay. So another one I want to show you is there are a couple of other formulas which are very helpful. So in this example, okay, I need to get the possibility of, let's say, in all the 10 coin tosses, okay, let's say I have 10 coin tosses, okay, and I want to get the possibility, possibility of getting, uh, let's take 6 heads, okay, 6 heads, uh, okay, so then how do you count? Okay, then you have this function called combin, okay. So basically, it will show you how many combinations are possible. So I'll say combin. I'll say out of 10, if you have 6 heads, what will be the combination that I have? Okay, 6 heads in a row. That is. Okay, so that is combin. Another thing that will help with calculation of probability is this one, binomial distribution, which basically has a few simple parameters. So you put the number, okay. So I'll put, let's say, see, because we are working with a binomial figure, right? Binomial experiment, which is a coin toss. So I can put numbers, okay, which is basically how many tosses I have, right? Wait, yeah. Out of that, I want to know what are the trials, right? So which comes up to a total of, so wait, I'll just show it here. So this is a number of coin tosses, right? That we need to count, which is 4 right now. Trials is actually how many things are possible. Okay. Then the probability for each for one coin for one coin toss, right? Which is 0.5. We already know this. This you'll have to calculate, and then you just put false because we want a probability figure. Okay. If you put true, you'll get some other kind of figure. If you want to read through it, you can just press the effects button and it will tell you what each of these buttons, what each of these fields do. Okay, so this one it says is a logical value. For the cumulative distribution function, use true. For the probability mass function, use false. So we need the probability figure, right? So that's how you can use the binom dist function also. Okay, so numbers, okay, what you want, the trials, which is the total number of possibilities, probability for each trial, and just put false. Okay, that will give you the same number. Okay. So these are the different methods you can use to just get the probability in Excel. Is this clear? Any questions? Guys, if you want to try this out, I'll give you 5 minutes. Maybe try the binom dist function out. Then you'll be more clear. Yeah, I've muted myself. Has everyone been able to try the binom distribution? I just didn't want the music to come. So some people prefer doing the maths and some people prefer doing the formula. Whichever way, it's up to you. So in the meantime, guys, can you? I hope you're not thinking of where you can use this in your own work. Um so if you have any interesting examples you have thought of, then you please share anytime you can. Should I move on to CLT? Yes or no, guys? Or you want some more time to practice? Okay. Okay. Everyone else? Looks like they're still trying stuff out. Okay, I'll wait for a couple of more minutes and then we'll continue. Okay. By the way, Arnav, I'm curious. Does this session seem like a simpler introduction than what you've done in your undergrad? Huh, okay. So Arnav, where to calculate? You'll just have to. Oh. Okay, this doesn't seem simple enough. Okay. I guess the stats as a subject is like that. However much you try to make it simpler, it's really tough to make simple. Okay. So where you calculate and write the answers, you write them in the Word document itself. Okay. And maybe you can copy paste the formulas, or you can just attach an Excel sheet and send that also. Both are fine. Yeah. True. Okay. So usually in like a class environment, they'll have a lot of time to go through each and everything. Here we don't have. I think someone had put yeah. So this is a very reputed statistical this. Yeah. So this is again the third year. I think you must have gone through something similar to this. Yeah, no? Where they have like each and every semester, like for example, there's probability. Yeah. So probability they take it through. I think a couple of years. Yeah. These two terms in the third year first term. So they have a lot of time. Yeah. Yeah. So they go through everything in depth, detail, but we don't have that much time. We'll just take the essence and be able to use it somewhere, right? Okay. Okay, I think everyone's done with probability. Okay. Guys, even if you're still trying something on probability, leave it. You can continue later. Let's move on to CLT. Okay. So CLT, I'll come to these, okay, what these numbers mean in a little bit. But before that, I'll just show you how to take out samples properly in Excel. Okay. So this is a slightly new thing. Um we have like a couple of we have this set of variables here. Okay. So if I just click run, uh, okay, sorry, that didn't work. But okay, that's fine. Let's ignore that. You have this set of variables, okay, which are I think, yeah, 1000. Okay. So you have this set of 1000 variables, and the goal is to get a random sample of 30 every time, okay, or 100. Let's take a sample of 100, okay. So we want to pick out a random sample of 100 data points from this whole list, right? So the way to do it in this in Excel is you don't go manually and go try to like cut paste or copy paste. There's a much better way to do it. You can actually go to the data tab, and I have this data analysis tool pack here. Okay. If you don't see this, then what you have to do is you go to the file menu. Okay, guys, please pay attention here now, because you have to turn a certain setting on to be able to see this. You go to the file menu, you go to options, okay, then you go to add-ins, and within Excel add-ins, you just press go. Okay. So I think you must have already learned the solver, right? In the same place, if you want, if you're not using the solver, you can turn it off, and you make sure you turn on the analysis tool pack and the VBA one together. Okay, just say okay. That will make sure the data in the data tab in the ribbon, you will start to see the data analysis button here. Okay. Just say done once you can see the button here. So I know I'll move forward. For those who didn't get it, still it's in file options, add-ins, and you have to click go here. That's where you'll find it. Okay, two people are done. What about the rest? Already have it. Okay. Okay, I'm assuming everyone must have had it. I'll just continue. Um, okay, so when you click on data analysis part on the add-in, right? There are a few like preset add-ins here you'll get. Like the one we need right now is sampling. Okay, so just scroll down a bit if you can't see it. Click on sampling and click OK. Or you can even double click, right? And basically this tool is there to help you extract samples. Okay. So my input range would be this. Okay, if you're taking the label, make sure you have labels checked, right? So I'll just check labels and uh, take this whole uh, column, right? Then my sampling method would be random for now. I'll just take 100 samples out of this whole list, okay? And I'll put this output in this cell here, okay? So from here onwards, it will put the list out of 100 numbers, okay? So if I say OK, it will just extract the whole sample and dump it here. Okay. And all of these numbers are only those that are present in this list. Okay. So you'll see I'll get 100 numbers of samples. Okay, you see the count here. Just do this much, everyone. Has everyone been able to get a sample? Yes or no? By the way, if ever you don't have access to the data analysis toolpack, you can also use formulas to get a random sample, but that will take a little longer. Okay, this is the shortest method. You can use a random function and then do a VLOOKUP for that. Okay. So Arnav, it has to be in the data tab. So maybe you might be able to see only the icon, not the word, but it will be towards the end. If you want, you can share your screen. Okay, I'll just make you presenter. Just 1 second. That'll be faster to solve. Okay, Arnav, I'm making you presenter so that yeah, you need to add the add-in. Right? How will you get it? So just share your screen. I'll guide you through it. Okay, Arnav? Yeah, we can see your screen. Okay, go to the file menu. Go to options, add-ins, go. Just press go next to Excel add-ins, the go button. Yeah, and you turn on the first two. Yeah. If you don't need the solver, turn it off. It will make Excel a little faster. Okay. Now you should see it. See it's come. Okay. Anyone else who needs help? You just saw Arnav do it. You should be able to. Yeah. Welcome. This is why I was asking. Everyone got it or no? There was no replies. Guys, see if you don't be active on the chat. Sorry. If you're not active on the chat, I won't know what is happening on your side. You're not sitting opposite each other physically. So please be active on the chat. Yeah. Okay. Got a sample, everyone? Yes or no? I know 2 people have, 3 people have. Okay. So CLT basically you have to find out. Okay, we'll come back to CLT a little later. I just wanted to show you how sampling is done. Okay, in Excel through Excel. Um, in the meantime, I'll just take you. First, we have to understand all of this. Then we'll circle back to CLT. Is that okay with everyone? Madam, what is there to check? You just check if you have 100 numbers, right? If you have exactly 100 numbers, it's good. Okay. And as long as you selected all this whole like variables, all these variables, it will naturally come from this set only. It will not put random numbers here. Okay. Yeah. There's nothing much to check here. Okay. Um, fine. Let's go to histogram. Okay. Now, guys, I'm just introducing you one by one to the data analysis like features, so you're comfortable using that. You can do all this through formulas also, but it's just a longer cut that way. Okay. So another thing is age. Okay. So we have another list of variables here, which is age, right? And we want to kind of group them and get a frequency chart, right? A histogram. Uh,
Hello.
yeah, Madan. Hi.
Hello.
Yeah.
Sorry to disturb you, sir. The table that is there, variable one, in the sheet
Yeah.
CLT,
Hmm.
there are certain terms like standard error, sample variance,
Yeah, we'll
photos.
go through all this. We'll go through all this. Okay. Then we'll
Okay.
come back to the CLT sheet and actually do a CLT. Okay, just to test. Okay.
Okay, sir.
Yeah.
Yeah.
Yeah. I'm glad you brought that out, by the way. Guys, please ask the question. It will make the session more interesting for you and me also. Okay. Uh, Fine. So histogram, we have this whole list of ages. Okay, and we want to group them into bins. Okay, bins are nothing but groups or bunches, right? So, Madan, you can just mute yourself, please. There's background noise.
Okay.
Yeah, thanks. So bins are just groups. Okay. So all I've done is written out the different groups I want. So suppose I wanted groups of 20, I could have just made bins or bins to whatever of 20. So I can start with 10. Sorry, 20, and just do plus 20 from there, right? I can just do it this way also. Okay, so now I'll have groups of 20 each. So let's go with this one for now. Now, how do you categorize all this into within these bins? One thing is you can do formulas and just do a count if, okay, count if less than 10, less than 20, and so on. Are you all clear on how to do that via formulas? You all have learned all this in Excel, so I'm not repeating this. Okay. What I'll show you is the data analysis part. So, for example, if I go to data analysis and I go to histogram, okay, I can click on OK, and my input range will be this. Okay, my bin range would be these bins. Okay, and if you're selecting the first words over here, you just click on labels. Because I've not selected them, I'll not check this. Um, and just like pivot tables, you can put them, put this histogram wherever you want. I'll just put this here in this same sheet. Okay. Uh, yeah. And if you click on chart output, it will give you a chart like this also. But I won't click that for now. I'll just say OK. Now you'll see it will neatly group all your ages into bins for you. Okay. Similarly, just to show it to you again, I can do it with this also. I'll just go to data analysis again, histogram, and instead of this bin range, I'll take this bin range. Okay. And I'll change the output to some other other place. And the moment I click OK, I'll get this kind of bin. Okay. Now can everyone try this much? Then I'll move on. Okay. Say done once you're done. If anyone is stuck somewhere, it's simple enough, but if you're stuck, just ask. We'll guide you through it. Okay, Diptesh is done. Hiral also. Those who are done can try to make a simple column chart on whatever you have. So, for example, if I go to insert, I can just insert a column chart to get the sorry, I selected the wrong things. So, column chart. And then this has to change to. Oh, well, by the way, guys, does everyone know how to change the labels here? Like, for example, uh, my bin labels are different, right? It says 1, 2, 3, 4, 5. But actually, it should have been 20, 40, 60, 80, 100, right? Yeah. So what you do is you just go to, you click on the chart, you go to chart design, you go to select data, and for your legend entries, you just go to add, sorry, not add, edit, and you just say series name के लिए you click select these. Okay, that will become a series names. Sorry, I did something wrong here. Oh, my bad. It was the horizontal axis, no? I put it on the legend entries. So horizontal axis, you just edit that and change that. As you can see, it will update here. Okay. Okay. Come on, guys. Has everyone tried the bins? Only 3 or 4 people have said they're done. I think statistics has put the rest of them to sleep. Okay, so this was also done. Okay. So if you have Excel 2016 onwards, I think you also get this ready-made histogram chart, okay, which can be useful sometimes. So for that, you don't need to define bins. You can just go to the list and just select histogram. Okay, that will automatically make a few bins. But I prefer to go through the data analysis part just because I can define my bins. Okay, done. Okay, great. So now you know how to create histograms also, and you know sampling. Okay, should I move on, guys? Yeah. Okay. So this next sheet here, distributions, is basically just to show you visually how the shape of the data changes. Okay. So we have a histogram here, and not a histogram, it's just a chart. If I just click on randomize, you'll see the shape keeps changing, right? Okay. And now if I increase and decrease one of these, you'll see how the uh, shape of the distribution changes. Right? Okay. This was just meant to be visuals. There's nothing much to it. The main thing we need to come to is data simulator. Okay. Now this is where I'll explain some of the things that you saw earlier in the CLT sheet, right? So first of all, we'll get an understanding of how the averages work in Excel or in general, right? So let's just go through that first because that takes a little bit of understanding to do. Okay. So there are three main types of averages. There's the mean, okay, which is the arithmetic average. Um, there's the median, and there's the mode. Okay. So the mean is what we actually do in Excel average, right? AVARAGE. This is the mean. Okay, it will calculate the arithmetic mean. Okay. This is basically the sum of everything divided by the number, right? I hope everyone knows this. Yes or no, guys? Yeah. So that is the mean that we are used to, the average we are used to. Okay. Then there is the median. Okay. So median is nothing but the middle number. Okay. Median is nothing but the middle number. So if I have 1, 2, 3, 4, 5, 6, can anyone tell me what the median is here? Let's take 7, sorry. Okay, what's the median here? 4. Perfect. Okay. Suppose you didn't have 7, you had an even number. Then what is the median? Does anyone know how to get that? Yeah, 3.4. 3 comma 4. No, it's 3.5. Correct. Okay. Perfect. Arnab, Arnab, he studies stats. He is given the actual definition. Average of the middle two values. Okay. Yeah. Perfect. Perfect. Oh, Madan says no median. There is a median, but you can't see it here. Okay. So it's actually the average or the mean of these two middle values. Okay. This becomes the median. Yeah. Oh, sorry. Okay. Then you have the mode. Okay. Mode is simply the most frequent number. So there is no mode here. But if I just add some random numbers here. So now, is there a clear mode? Yeah. This is supposed to be 3. So mode is basically the most frequently occurring number. So what is the mode from here? From this list? 3. Perfect. And you can also use median, okay, as formulas. So the median in this list would be 3 and the mode would be, I'm sorry, let's just take the simple mode. Okay. The mode would be free. Okay. Great. So this is simple enough to understand. As you understand this little more deeply, you will start to figure out which one to use where. Okay. If there is time, we might circle back to which one to use where. But for now, just understand there are 3 different types of averages. Okay. Fine. So that was the mean median mode. They are also called the measures of central tendency. Okay. This is a more elaborate way of saying the same thing. Okay? Because you're basically trying to find the middle point of the entire data set, right? That's what the averages do. Okay. Frequency you already know how to count, right? Just say equal to count. Okay. That is your frequency. Okay. Another method I showed you was in histograms is how to divide the frequency into groups, into bins. Okay. Then you have bounds, which is the maximum and minimum. Okay, which is the very edges of your data set, right? That also I don't think I need to explain. Statistically, they are called bounds. Okay, and then you have spread. Okay, which is how spread out your data is within these bounds. Okay, this is determined by these 3, measures. Range is the simplest. Then we'll study variance a little bit, and then I'll explain how to come to standard deviation. Okay. So range is nothing but maximum minus minimum. Okay. So if we say this is a very common word actually, range. It means the same thing. So if I say the range of uh, uh, models that this car company has, right, is huge. What does that mean? It has a huge variety of cars, right? Okay. Or if a star is told, let's say if I say Amitabh Bachchan has a huge range of fans, that means his range of fans range from, let's say, very small kids to really old people, right? So that is range. Okay, means exactly the same thing. Okay, and it's nothing but the maximum minus the minimum. That's the range. Okay, guys, if you want, you can take notes or you can just refer to the recording later. Max minus min. Okay, that's range. Now variance. I'll just explain using this sheet because it's easier to do it visually. So variance is basically do you see? Okay, so I'll just explain this chart first. Sorry. Okay. Um, so this is basically a scatter plot with all these points plotted on. Okay. So it's these numbers that are plotted on. Okay. Uh, does everyone know how to make a scatter chart? All you have to do is select your numbers. You go to insert and you just select scatter plot. Okay. That's all you have to do. Okay. So now based on these numbers, you see the red line here. That is the average. Okay. Now this is not a feature in the chart, this is just drawn manually, just to make it visually, you can see it visually. Uh, so once you get the average, right, the distance between each point and the average is the variance. Is this clear? So all these green arrows, right? So right now the variance for this first point is minus 25.3. Okay. For the second point it is 26.7. Right. For the third point it is minus 14.3. Is this clear to you, everyone? Okay. So how you do this mathematically here is once you have the list of numbers, you just find the mean. Okay, using the equal to average formula, right? Then you just find the differences. Basically, you have to just minus the mean from the minus each number from the mean. Okay. Uh, that is basically the differences, right? And once you square them, okay. Now this is a very key part to understand. Why do we need to square the differences? Okay, I'll just explain that. Then you'll understand why you need to square it also. Once you understand why you need to square it, you'll understand variance and standard deviation together. Okay. I had a sheet somewhere. Y square. Yeah. Okay. So I've set up another example here. Let's say we have these 4 as data points. Okay. Now if I just take the average, what will it be? 0. Right? You have plus 4 and then minus 4, right? It doesn't make sense like this. But the moment I square it, okay, what happens to a number? What happens to a negative number when you square it? Can anyone tell me? Yeah, plus, right? So minus minus becomes plus, correct? So that's the only reason why you need to square the numbers. Okay. So for example, I have this, right? This is the difference that I found. Okay, because if right now 0 doesn't make much of a difference, right? It's the same data set. But the moment I square it, then it makes sense to get the total, right? And you can also get the variance amounts. Okay, so now I know the average is 16, correct? And I can actually get the variance out of this. Okay. Uh, so the mathematical formula to get variance would be you get a sum of all the squares. Okay, you add up all the squares, so you get the squares to negate the negatives. Okay, you add up all the squares. Then the next step is you just divide the total by the uh, count. Okay, so right now the count is 4. Okay, we have 4 data points. Okay, so just divide the total by the count. Okay, that is your variance. Hmm? And then to get the square root of the variance is basically, standard deviation is nothing but a square root of the variance. Okay, so we take a square to remove the negatives. Okay, and then to get rid of the squaring, we again go to square root. Okay, which becomes the standard deviation. Is this clear to everyone? Are there any doubts? I'll explain again if needed. Okay. Okay. So I'm assuming everyone understood. Here's another example with a few different numbers. So you have, it amounts to the same thing, it comes to 0. Okay, but the moment you square the differences, the moment you square the data points and then get a total, you'll be able to get like a good average of it. Okay, so this becomes your variance, right? And then if you get the square root of this average of the squares, that will become your standard deviation, right? Now, every time you need to get the variance or the standard deviation, you need not go through all this. This was just to explain it to you. You can just easily do a standard deviation, STDEF, right? Equal to STDEF. And there are two versions, you'll see that. Okay, STDEF T and STDEF S. So the P stands for population and S stands for sample, right? So because I have the entire data set here, I'll take the standard def P. Okay. If you have just a sample of the data set, the formula changes slightly, which I won't go into now. If you want, you can read that up online by what the difference between the two formulas are. But I'll just go to standard deviation P for now. Okay. And then I can just select the numbers. Okay. That way I'll get the same standard deviation that I've arrived at. Is this clear to everyone? Yes or no? Okay, fine. So that was your standard deviation and variance. Okay. Again, both of these are measures of spread. Okay. So how spread out your data is, right? So again, if I come here, uh, when I say standard deviation is 27, okay, it means each point is approximately 27 points up uh, away from the average. That's what it basically means. Is this clear to everyone? How to interpret the standard deviation? Make sense? Okay. So you can also think of it like this. Okay, average is the average of the numbers that you have, and standard deviation is the average distance that each of them have from the middle point. Okay. Okay. So I think this should be clear enough to you now. I'll just explain a few of these other numbers, and then we can circle back to CLT. Where's that gone? Yeah. So standard error we'll see this later, much later actually, next session. Okay. I hope you know the mean. Okay. Median and mode also are clear to you. Standard deviation and variance also are clear to you. Okay. I'll come to these two, kurtosis and skewness. Okay. Uh, Again, if I show this visually to you, it'll be very simple. So I've drawn these few charts here. So I hope everyone recognizes the normal distribution. Yes or no? Yeah. So kurtosis is basically how narrow or wide this distribution is. Yeah, the first one, this one. Okay, I'll just draw boxes around it. Okay, this one. Oops. Yeah. So this one is your normal distribution, right? Now, if as you can see, this is more like a bell curve shape, right? But let's say you have something that looks like this, where a lot of the data is in the center, okay, and very little data is in the tails, right? That is called as kurtosis. It's a measure of how thin your curve is, right? So the thinner the curve, the more data you have in the towards the average, the center line, correct? So for example, if I have to draw the average, it will be somewhere here, right? Correct? I'll just change the color so that you can make out. Okay. So if this was a normal curve, the average would be somewhere here, the green line. Okay. Now, as you can see, if you have a lot of kurtoses, that means you'll have a lot of data in the towards the average. Okay. Unusually more. It'll not be like a normal data set which is like equally on this side and that side, right? You'll have very little data in the tails again. Okay. That is kurtosis. Is this clear to everyone what kurtosis means? Yes or no? Yeah. I think visually it makes it very simple to understand. So I just do this. Okay. Now skewness is again, suppose I put my average here. Okay. Now skewness would mean my data is tilting away from the average. So most of my data is not on the average line. Okay. So now if you have some scenario, like if you have skewness, usually what you'll see is your uh, I'll just change the colors. Your mean, median, and mode will have three different places, something like this maybe. Okay. So these three lines here are the mean, median, and mode. Okay. Usually it will become like this if you have skewness. Okay. So it also means if you have a normal distribution, all your mean, median, and mode will be on one line. Okay, they'll be together. They'll be exactly the same. But the moment you have skewness, you'll have some difference in the mean, median, and mode. Is this clear to everyone? Yeah. Okay. And finally, you have kurtosis and skewness together, which will look somewhat like this. Okay. Which is basically you'll have skewness also, and if you have kurtosis, it will be a really thin line here. There'll be like a lot of data in a narrow band. Basically, that's what it means. Okay. Again, this also will have a different mean, median, and mode. Okay. So I hope this kind of little drawing has made it very clear to everyone. Yeah. So you can have negative skewness and also positive skewness. So if I have this here somewhere, okay, okay, this also is another kind of skewness that you can have, right? If I change this to make it more smooth, okay, then this has very little kurtosis and a lot of skewness, right? But if I have it like this, I'm sure everyone has seen charts like this, okay? This has kurtosis and skewness, okay? So that's all it is. It's just fancy words for simple things, okay? So now I am assuming everyone knows how to understand this whole thing except standard error. That will come to next time. Yes or no, guys? If you have any questions, you can ask, please. Yeah. Okay, fine. So I have one final thing to show you is how to create this. Okay. Uh, Once you know how to create this, then I'll leave you to just practice CLT. We'll actually take out 30 individual samples and test out whether CLT works or not. Okay, that's the last thing we'll do for today. Yeah. So if you want to calculate all of these stats on a certain data set, all you have to do is select the data, okay, or actually let's go to data analysis, and you go to this thing called uh, descriptive stats. There, descriptive statistics. Okay, that's what we need. Right? You say okay, and basically you select the input range. Okay, whatever you have. I've not selected the whole thing. You have to select all 100 numbers from the sample. Okay. Uh, if you've selected the label, you say labels in first row. and you select the output range. Okay, so I'll just select this for example, and you click on summary statistics. Okay, that's the main thing. You click on summary statistics and you say okay. That will give you like a whole summary of whatever you've selected. Is this clear to everyone? Yes or no? No? It's very easy. It's better than doing one formula separately. Okay, and it formats it very well also for you. So yeah, that's what we have to do. So if you see here in the CLT sheet, we have one descriptor stats done for the variable, okay, and we have another one done for the sample, okay. So CLT will check it using, we'll actually take out 30 samples, okay, and we'll check the mean for that, okay, the mean, okay. So for example, I'll just do a couple so you know what to do. So let's take this as my first sample. So I'll say S1, my mean is this, right? So I can copy and paste this here, or you can also do equal to average, okay, because we are just looking for the mean number, right? We are not looking at all these other numbers as of now for CLT, right? So I can use the mean formula, or I can just copy paste this value here, whichever way is fine, okay. This is my first sample. Then for my second sample, I'll go back to data analysis. I'll go to sampling, say okay. My input range would be this whole thing, right? I'll take 100 number of samples every time, and my output range will be C2 again. Okay, I'll click on OK. Now because I didn't delete this old sample, it is asking me output range will overwrite existing data. If you press OK, it will just replace it with a new sample. Okay. Now if you've done an average formula, just remember to paste as values because your old one will change. For now, I'll just copy paste this from here. Okay. Now my sample 2 becomes this average, right? Now he's put a macro here so that you can just click on this to get the data analysis run for you. Okay. If you want, you can go through the whole you can go to the whole data analysis thing and do the sampling again, and you can replace this sample. Okay. Sorry, I'll just undo. Okay. For now, I'll just do the average and get this out. Oh, sorry, this is the sample for the second one. Okay, anyways, I'll just make this first sample. But you get my flow, right? Like this, you have to get at least 30 samples, okay? And 30 means for different samples. And we'll see how close they get to the mean of the whole population, okay? Of this whole population. Is this clear to everyone, what you have to do? Yes or no? Yeah. So just start doing that. You have like the up to 1 o'clock. Just get 30 samples and we'll check if this works or not, okay? In the meantime, if you have any questions, ask. Oh, by the way, sorry, I'd almost forgotten. Uh, we had to come back to explain the third point, right? Madan, were you going to remind me of that?
So I have one small query.
Sure. Ask.
So I work for a pharma company.
Okay.
My job is MIS plus SFA, that is Salesforce Automation.
Okay.
Now this statistic, what you have taught, how to use this, say, for a professional working in a industry. Do we have such examples? For example, how to use standard deviation in my work. I hope I am clear.
Yeah, you're asking for a real world example. Okay. So,
Yeah.
from your field, you basically look after pharma sales, right? So you have to do
I'm
MIS
into
meaning for sales, right?
data,
But what kind of data?
internal data,
Internal data, okay.
uh,
Okay.
internal as well as external.
Okay, I'm not able to think of a good example for that.
I was just thinking, sir, if say
Hmm.
target versus achievement
Hmm.
and taking off by zonal managers,
Hmm.
standard deviation I can use, right? 1, 2, 3, three standard deviation, as in 64%. Can that be applied over here?
I'm not sure because I'll have to see your data. See, you'll know your data better. I'm not familiar with the data, so I won't be able to tell you what stats you can do on it.
Achha.
So the idea is
Uh,
just, so I'll do one thing. Next session, I'll come up with a few examples from different industries. Okay, that will help everyone, I
okay.
guess. Okay.
Okay.
In the meantime, Madan, what you can do is you try to see where you can use this in your own data. Okay.
Okay.
Yeah. So Diptesh has written rightly. I think it depends on what you want to find out. Okay. So again, we are coming back to the original thing of your questions are more important than answers, right? So,
Basically I want to say take a decision
hmm.
of non-performer to be removed. Say my
Yeah, that's a good.
want to take.
Okay, so I'll tell you one thing. Next session we are going to find out. We are going to learn how to find out outliers. That will help a lot. Okay, you've given me a good example. So when we learn that, you'll basically know how to figure out who are the topmost performers and who are the bottommost performers. Okay.
Right,
So
right.
next session we'll be starting with outliers. Okay.
Okay, sir. Okay.
Yeah.
Thank you very much.
Yeah. Welcome. Yeah. Coming to the third point. Uh, let's find that. Huh. Okay, this is going to get little technical, so only those who want to understand this can pay attention. The rest can continue with CLT. Okay, so all the variances will be approximately equal to the variance of the population divided by each sample size, right? Uh, so, okay, let's take this sheet as an example. Okay, that will make it easier to understand. So, suppose right now we are finding out the means, right? We are checking for this point basically, right? Similarly, if you want, you can try this on your own for variances, right? So for example, we find out 30 variances for all these 30 like samples, right? Suppose this is mean and variance, right? So if we find out the variance amounts for each of these 30 samples, right? What this point is saying is basically the variance of the population, okay? The variance of the entire population, which is this, right? uh, will be approximately equal to the variance um, of each sample size. Okay, so sorry, so each sample's variance that we get over here. Okay, if we divide the whole data set's variance into 30, divide by 30, right? This number and this number will match, right? It'll be approximately equal. Is it clear enough now? Diptesh and Madan and whoever else is listening. Yes or no, guys? Yeah. Okay. So like we are trying to test for this mean is equal to this mean, right? Actually, this whole list of means should be approximately equal to this mean of the entire population, right? Similarly, we are trying to see if the entire different variances are approximately equal to the sample variance of the entire population, right? Is this clear, guys? Yeah.
Hi. Can you hear me?
Yeah, Dipesh, hi. Dipesh, you wanted to ask something?
Yes.
Yeah, please ask.
I just want to say that the you mean the 30 variances we are going to find out divided by the sample of the variance?
So, yeah. So this population sample, we'll divide this also by 30. Okay, divide by 100. Okay, because that's a sample size, right? Okay, now this figure that we get here, okay, we are trying to see if this variance is will be approximately equal to this variance that we calculated. Okay, that's what this third point is saying. See, so equal to the variance of the population divided by each sample size. Correct? Is it clear? Yeah, perfect. Okay. So for now, during the class, just make sure you test the mean at least. If you want, you can test the variance on your own also. Okay. Fine. In the meantime, if you have any other questions, please ask. I'm just pausing my screen so that I can copy the feedback link for today's class. There you go. So guys, I want to get an accurate sample. So make sure all of you fill the feedback. I want the entire population's feedback today. Okay. Hero, done as in CLT or the feedback? What have you done? Oh, thanks. That's okay. You can continue with CLT, okay? It seems all of a sudden a couple of people dropped off. Okay. Also, guys, please do the assignment. That way you'll know where you stand with statistics. Have you understood everything? If you have any, in fact, you'll have more questions to ask next time. Okay. So next time we'll begin with discussing the assignment, whatever questions you'll have, and then we'll go on to the next parts. Okay. Okay, guys. So I'll stop in a couple of minutes. I'll end the meeting, and yeah, at least open the feedback form and keep so that once I end the meeting, the link is not lost. Okay. And yeah, of course, please do your assignments. See you next time. Also, if we have enough time next time to cover everything, we can finish the whole stats by next session. The third session is just kept as a buffer because sometimes people have a lot of questions. It just overflows. So generally, the third session is needed for stats, but let's try and finish it in the next session. But that doesn't mean you ask fewer questions. And also remember to check out the video on the Galton board. Okay. Just reminding you. Okay. Okay. Bye, guys. See you next time. It was fun introducing you to stats. Yeah. Bye everyone. Bye.